So I'm Tasia Malakasis. I'm the CEO of the Company Lab in Chattanooga, Tennessee, where we support startups in the energy, mobility, and now quantum space. And I'm honored to be your moderator for this panel, Building Quantum Ecosystems in Emerging Markets. And I've got an amazing panel here, and we're going to talk about, there's been a lot of talk today about partnerships and collaborations, but we're going to talk to you about an ecosystem that is really working in this way. But there's been some breaking news today, so I'm going to share some of that breaking news with you all. It was from EPB, and I've had a tutorial on how to do this. Y'all bear with me really quickly. I got it. Now what do I do? Here's my famous. Oh, you got me.
Did you call for technicals?
I did, and he's been standing right next to me, and
Exactly where he needed it.
okay.
Oh, I've seen many of you at the booth.
Your loftiest visions about quantum are closer to reality than ever. Because in Chattanooga, Tennessee, at EPB, quantum is on. We've been making real-world quantum innovations for a decade. 2016, EPB partners with Oak Ridge and Los Alamos National Labs to develop one of the first real-world quantum cybersecurity systems for the U.S. electric grid. Work so groundbreaking, it earns an R&D 100 award. 2023, EPB launches the nation's first commercially available quantum network, putting Chattanooga on the map for innovators around the world. 2025, EPB takes delivery of IonQ's most advanced quantum computer, setting the stage for what comes next. 2026, for the first time commercially available quantum networking and quantum computing in one location, now supported by classical supercomputing. Through an agreement with Oak Ridge National Laboratory, the EPB Quantum Center is now home to an NVIDIA DGX system, creating a truly unique hybrid quantum ecosystem.
That's the power of the EPB Quantum Center. It's the only place in the nation giving entrepreneurs unprecedented levels of access to cutting-edge quantum resources, turning their boldest quantum visions into reality.
I'm really excited for what this partnership will continue to hold as EPB's vision combines with IonQ's hardware. I can't wait to see where we go.
Quantum for the real world. In Chattanooga, Tennessee, it's on.
Beautiful. Okay, so my technical best friend is going to put me back on the right track. So what we're going to talk about today, it's what I think is really, truly remarkable, is how a mid-sized city like Chattanooga is leading in the global quantum technology space. And we're talking about emerging markets. Chattanooga certainly, again, is a mid-sized city, but they started, EPB's at the center of gravity of this, ground zero. This started this whole space with developing, with the help of a startup, Silicon Valley-based startup, developed the nation's first commercially available quantum network, and soon to be the nation's first quantum network co-located with a quantum computer from IonQ, and the news today also with HPC from NVIDIA and Oak Ridge National Laboratory. So we have this really fantastic ecosystem here. Now, EPB, as I mentioned, started this, but what came into being is some of the people that you see here on the stage are going to talk about what that collaboration means that EPB started, and hopefully demonstrate that an emerging market can be a model for the rest of the country. So I've got this great panel. I'm going to let them kick it off by introducing themselves and also answering a quick question. What excites you most about Chattanooga's role in quantum innovation? So give me like 30 to 45 seconds on that after you introduce yourself.
Excellent.
Are you good? Do you need that?
Oh, sure, yeah. So I'm a senior director at IonQ. I lead the technical sales teams. And we, of course, are responsible for explaining all the products that IonQ is selling. What excites me most is that this collaboration with EPB is really inspiring other regions of the United States. It also fosters innovation. Think of the early days of machine learning, where we just had things that we could just try, right? And opening up that ecosystem, making it user-friendly, making useful results out of the product and the hybrid applications is very exciting.
Hi, everyone. I'm Janet Rehberg. I'm the President of Strategic Initiatives at EPB. What excites me is that it really fulfills our mission of improving the quality of life for our community. So everything that we do is helping to accelerate the quantum space. We hope that it's going to provide the benefit that it did with our fiber network. So EPB has one of the most advanced smart grid or automated grid in the nation, as well as the fastest internet up to 25 gigs. And our network, our fiber network, has shown so much community benefit that we see that quantum is that next wave that could really help benefit our community. So I'm super excited to be part of a company that could help accelerate that.
Great, thank you. Charlie Brock, I'm CEO of the Chattanooga Quantum Collaborative. So we're a 501c3 that was stood up to run alongside EPB and other partners to really help push innovation, to push economic development and workforce development for our region, utilizing quantum assets and developing partnerships across the region, state, and country. And what excites me most is you've all seen, I'm sure, the McKinsey study that talks about $1 to $2 trillion in business value, economic value, over the next 10 years from quantum. They also talk about those who, in several industries, to get early mover advantage. We are well positioned now with investments that EPB has made to be that first place for early movers to come develop applications, to work with researchers, universities, and test that on our commercial network and on the soon-to-be commercially available quantum computer. So super excited about that.
Hi, I'm Rick Mukherjee. I'm a theoretical physicist by training. I'm the director of the newly formed Quantum Center at the University of Tennessee, Chattanooga, and the associate professor in the Department of Physics at the University of Tennessee, Chattanooga. We just completed 1 year of our anniversary of the Quantum Center. Some of you may see there are some bookmarks and pamphlets on the table. Feel free to pick one, and you will get to know more about our Quantum Center. What excites me about Chattanooga is that we have been talking a lot about how fundamental science research and education should translate to solving real use cases in the world. And for that, you need a collaboration between university and companies like EPB. And in Chattanooga, that's exactly what's happening. So it's not just an idea, but actually something that's being put to practice. And that's a very exciting thing for me.
Thank you. And if you'll pass the mic back to Nicole, we'll start with you. As EPB prepares to bring on an IonQ quantum computer, what kinds of applications or pilot projects do you expect to emerge first in Chattanooga?
Great question. So the initial focus is going to be on the business of EPB, right? So energy generation, energy optimizing the grid. So think of optimization, quantum machine learning, but the reach of that. So EPB has in mind of extending that ecosystem to the industries all in that region, to startups, to graduate students. So a lot of those learnings will be translated across the industries in the Tennessee region, right? Think of the financial industry, the healthcare industry. And what IonQ brings to the table is we have a lot of this experience to transfer first to the EPB team, and then from there, a multiplying effect across the region. So very exciting. There's also a narrative around machine learning. So even in the large language models, that work will remain mostly classical, but there is a story there for quantum computing, and we look forward to experimenting with that, expanding on the use cases, and getting real advantage out of the quantum computer.
Janet, I know the video highlighted some of the history of EPB in this space, but could you walk us through that journey with the awards and how you worked with the startup and how just walk us through that whole journey in a little more detail, if you don't mind.
I'd love to fill in the gaps. So the video did a great job with the timeline. As you can see, EPB got into quantum almost a decade ago, and I really want to give kudos to two gentlemen that's in this room that had the innovative mindset to really start the discussion on quantum for EPB, and that's David White, our CEO, and Jim Ingram, our Vice President of Strategic Research. In 2016, In 2016, DOE wanted to do a pilot project using quantum key distribution. So they gathered a small group of people. They had Oak Ridge National Lab, Los Alamos, Cubatech, which is a startup quantum company out of California, but they needed, talking about grid security, they needed a electric utility. So they actually had a utility in mind in California that pulled out last minute. And so with EPB's reputation in the fiber network industry, they gave EPB a call and got a hold of Jim Ingram and David, and their innovative mindset said, we would love to be part of this project. And DOE actually said, we want to see if you're going to be part of this, but you have 48 hours to respond. And so I'm very appreciative that our leader took the initiative to be part of this. Quantum was something that was very new at the time, 2016. We did a little bit of research of it, but really didn't quite understand how much opportunity it was. Through that partnership, we learned a lot from it, and the partnership won the R&D 100 because it was proven successful going short distance to secure the grid. And our CEO, David Wade, saw the opportunity that a lot of quantum work was in the lab, and he thought, what an opportunity if we can actually commercialize it so that companies can actually come and test their product on our quantum network, and that whatever IP that they create during that time, it's theirs to keep. We won't take any part of that if they test it on our network. So that's how we got ventured into that. And since we worked with Cubatech, that's the company that helped us build our quantum network. And Cubatech last December 2024 was acquired by IonQ. And so as we look at the McKinsey study, it says in the next 15 years, 2040, there's going to be trillions of dollars invested in the quantum space and helping the economic development of the communities that are first movers. So we wanted to continue to be part of that. So, having a quantum network, we knew that it would be a great opportunity to add a quantum computer. And our board approved it in April of this year. And so we're in the process of having IonQ Forte Enterprise that's being built at our quantum center and should be operational early next year. And then the announcement that we had today is that also the partnership with NVIDIA. So EPB's quantum center not only house a commercially available quantum network, going to have an operational quantum computer, but we do have an NVIDIA DGX box to help us to do some grid application, to help with the network and computing hours that other companies can come and utilize this infrastructure to accelerate that quantum space. But as AI gets more and more useful, it consumes so much energy. And we think that with the way the quantum superposition works, that it also could help with energy capacity as well, too. So there's multiple facets on why we got into quantum and how that could be very beneficial, not only to EPB, but to our community.
Amazing. So you're opening your doors for everybody to come and play. Yeah. Amazing. Okay. So Charlie, there's been a lot of talk these past 2 days about commercialization. Can you talk to us a little bit about how CQC helps create those pathways from lab to market? Right.
And I might mention the organization that you run, CoLab, in that conversation. And it really is. We've been working hard in Tennessee for the last several years of developing a continuum of support to get from lab to launch into successful companies or either startups or in licensing opportunities. And we've got something called the Tennessee Technology Advancement Consortium, which has all of our universities that are plugged into this program now. And it includes a variety of different support from SBIR, STTR matching grants to grant writing support to proof of concept funds and other things. And so really a great focus on getting from lab into launch. And now plugging quantum into that is a great opportunity. Also, our national lab, Oak Ridge National Lab, has several different programs trying to help get researchers and entrepreneurs to have access to lab resources and then out into the market. We've got a great example that's very topical. We had a company Oak Ridge had a company that graduated out of their 2-year program called Innovation Crossroads, and it's a DOE-funded program, just graduated in this last cohort. They were just accepted into the program that, one of the programs that Tasia runs, the CoLab Sustainable Mobility Accelerator. And so a company called Cuba Engineering will be moving from Oak Ridge to Chattanooga here in the next 2 weeks to start the program there. And it's an incredible way of how we tie in from industry, from research to industry to startups all across the continuum here. In this case, Cuba Engineering is working on grid optimization scenarios. So part of the program that Tasia runs is hooking up those startups that are coming into that program with industry partners. In this case, what great industry partners that we have here with Oak Ridge National Lab, with EPB, with Oak Ridge, also with TVA, with whom they've been working. We have a TVA representative here too. So we're really fortunate to have all the assets that we have in the investments and the players that we have in the energy space, and they're all very plugged in to and bought into what we're trying to do and making investments and supporting commercialization.
Thank you, Charlie. I appreciate you mentioning that too. We're excited about qubit engineering. Dr. Mukherjee, question for you. So from a research and workforce development perspective, what are UTC's priorities in quantum and AI?
Right. UTC started this quantum initiative in 2022, and back then already we came up with the Quantum Certificate Program, which is the first of its kind in the state of Tennessee, where undergraduates with different majors can take the certificate program and get trained in the space of quantum research. And we completed also, so that got kicked in 2023, 2024, we completed the 1-year anniversary of the Quantum Certificate Program, and I'm happy to say that one of the first cohorts, Jackson, was hired by the EPB Quantum Center. So, that speaks to the success of the Quantum Certificate Program. Along the lines of workforce training, we also have a Quantum Information Science and Engineering PhD program in the pipeline, which we're confident to get that started by the fall of 2026. So as a university, as the local University of Chattanooga, I think we can play a very strong role. We are playing a strong role, and we'll play a bigger role in terms of workforce development, because you need to train the students as early as possible, starting from the high school. So we had like a K-12 outreach program for the high school students to come to UTC and have a look at the lab. We have a quantum sensing lab. We have a quantum networking lab at the center. So it gets students excited already at the high school level. Then they sign up for the undergraduate program. They do the certificate. Then if they want to do further research and studies, they can do the PhD. And we also collaborate strongly with the Oak Ridge National Lab and EPB to do internships. So it's exciting for them while they're students to get their hands on to the machines, whether it's quantum algorithms running on the quantum computers via the cloud. We have a partnership with IonQ where we have an IonQ account, and we kind of give a hands-on experience of how to write these quantum algorithms and deploy them on a real quantum machine, and that's very exciting. Also, like working on the quantum nodes and on the quantum network. So there's a rich collaboration, not just across the different departments within the university, within the Quantum Center, but also across the city of Chattanooga, and then that also leads to outside to Knoxville with Oak Ridge National Lab. So we have students who go to the National Lab and have hands-on experience on research. And so that's a fantastic ecosystem we have, and UTC is playing a very strong role there.
Thank you. Okay, we're going to come back this way. Charlie, you're up next. How do you measure success when building a quantum ecosystem in emerging markets?
Well, in a qualitative fashion, we all want Chattanooga to be the first place that people think about when they want to test and build quantum applications. And whether that's a researcher, whether that's a startup wanting to build their company, whether that's a legacy industry wanting to be one of those early movers who's going to take advantage of that $2 trillion in business value, we want Chattanooga to be the place to go. I can go there earlier than I can go anywhere else, and it's a welcoming community. It's a community that works together, and they have infrastructure, investments, assets that nobody else has that are commercially available. And that's a unique positioning for us right now that will not always be unique, right? So the sooner we can continue to keep that flywheel going and take advantage of really the Chattanooga story has been, I'd say a couple of different things. It's been investment in infrastructure as a platform for innovation and economic growth. And certainly EPB has been at the forefront of that over the last 15 years. And the other story about Chattanooga and the secret sauce is about collaboration, that we work really well together. It's not always perfect, but we are very tuned in to understanding what a win-win looks like, and really a win-win-win. What does it look like for each of the partners involved in collaboration, and what does it look like for our community? And if we do that well, and we keep our eye on alignment and making sure we all win in this, and we get the word out, I think we can do amazing things.
Thank you, Charlie. Well, I also like what Dr. Mukherjee wants to call Chattanooga too, is Quantum Valley, so we can live up to that too. Okay, Janet, you're next. So with both the first commercial quantum network and soon the first commercially available quantum computer, how do you see Chattanooga's role on the global quantum scale?
Wow. I think it's just very exciting that, when you think about something that's so innovative, that you think a small city like Chattanooga would be on the map. But actually, IonQ, Ryan Harring, I think Nicole's sitting in for him, he mentioned to me that he was traveling around the world to do some sales for IonQ. And he said when he went to Korea, they said, "Oh, you work with EPB? Tell us more about them." So it's just so interesting that the work that we're doing, the innovation that we're in it, is now sort of putting us on a map kind of globally too, which is great for our community as a whole to be recognized. And I think having this commercially available infrastructure, both networking and computing, is going to open up more opportunity to bring in startup companies, hopefully from all over the world, coming to Chattanooga and just make the community even better.
Beautiful. I love it.
Yeah, and I would add, global fame is, let's start with the U.S. fame too, because when we talk to clients and we say, "Oh, Chattanooga, we installed a quantum computer," like, really? Wow, I want one too. So in the U.S., we may only have 4 or 5 regional quantum computer hubs, right? Some clients will want to buy their own, big corporations will want to own their own. But as far as a quantum ecosystem that's available to startups, to students, to K through 12, right? To companies that want to build their competitive advantage for the future, right? Chattanooga is going to be like the shining example of how that's all going to work.
Love that. Keep that, because I've got one for you. So how does IonQ view Chattanooga differently than other test beds or research hubs?
So one of the huge advantages, right, for both of us, for EPB and IonQ, is the ability to test these use cases, help EPB also grow their ecosystem, grow the industry base, deliver real-world commercial hybrid applications. And by that I mean Chattanooga is positioned with the quantum computer, the NVIDIA HPC cluster, the networking, to really expand on the idea of what a hybrid application means. Ultimately, we want these commercial applications to add value to EPB, right? That's why people buy a quantum computer, right? Is to add value to their business. So we'll prove that out with EPB. We'll prove that out in the Tennessee Valley with their, with your data, with your constituents, right? So that's.
Yeah, thank you. Okay, so we've got 6 minutes left. I want to maybe leave a minute for some questions. So I've got more, but I think I'm gonna take us to a round robin.
Okay.
So to close out, so a future outlook. What is our biggest challenge to secure Chattanooga's leadership in quantum? And I'll start. Can I start at the end? We'll start with Dr. Mukherjee.
Well, there has already been, we alluded to the Mukherjee report about the $1 trillion industry that it's going to be in the future, and that's a conservative estimate. If some of you attended one of the session about quantum fault-tolerant quantum computing upstairs, and there was Jay Gambetta from IBM and Matthias Troyer from Microsoft, and they were all talking about the fault-tolerant quantum computing, how within the next 10 years it's getting there, and they were all talking about quantum post-cryptography and things like that. So there are fundamental research challenges that we need to work at, and that's where universities work closely with national labs, and so we have that beautiful partnership between Oak Ridge National Lab and UTC. And so that's a challenge not just unique to Chattanooga, but anyone who is in the quantum space, to understand about what it takes to get to fault tolerance, what it means to have quantum post-cryptography, and then comes the second challenge, once you have addressed those fundamental aspects of research, is where is the meeting point with industry? There's a lot of conversation in this conference about industry meeting research and universities and national labs. And we have partnerships with TVA, EPB. We have also UTC Quantum Centers working with Lufthansa on working on optimization problems. And we're building quantum algorithms for them. And it is a very interesting period where while we are working our way towards fault tolerance and getting to the scalability that we need, it is very important for us to understand what's the nexus where you can see quantum supremacy, quantum kind of having an advantage over the classical algorithms. What kind of problems, what size of problems, and how is the hybrid approach, and this is where this NVIDIA and IonQ discussion that we have been having is because we're not going to completely throw away our classical computers. So identifying the right problem for the real world use cases, addressing the bottlenecks at the fundamental research levels. These are these are the challenges that any university or industry in the quantum space are facing, and that will be true for Chattanooga as well.
Thank you. Charlie?
Yeah, I guess I would throw two words out, flywheel and scale. We need to get the flywheel going. It's starting, and you heard Dr. Mukherjee talk about some of the things as I think about the flywheel for talent, I think about the flywheel for entrepreneurship, and I think about the flywheel for capital. And it's starting on the talent side with some things that UTC is doing and other universities, quite honestly, across the state. It's starting now as we talk about Cuban engineering coming into Tasia's program. How do we really build that muscle memory and that capability to have more quantum startups coming in to take advantage of infrastructure that EPB is now invested in that we have in Chattanooga and at Oak Ridge National Lab? And then how do we get private capital? Because you've got to have the talent and the ideas and the opportunities to attract the private capital, both I'd say the venture capital and also to get industry capital. And how do we get them working on the pilot projects that we need to be doing with UTC and others? And then so it's a marketing challenge. But that's our opportunity. And again, I think we've got first mover advantage on that, but there's no time to waste because nobody's waiting on us.
That's for sure.
Yeah. If you mind, I just want to address, so a different perspective on the length of time required to make quantum computers useful, right? So there are some applications that require fault-tolerant quantum computers, others don't. And so one of the advantages of having an IonQ computer at EPB is as we scale up quickly and offer many more physical qubits with low error overhead, those are useful. Those are things that you can do quantum machine learning on, right? Because quantum machine learning, or machine learning in general, is a stochastic process, right? You don't need very, very low errors like you'd expect from a fault-tolerant quantum computer. So the foresight of EPB to start adding an IonQ quantum computer in their network allows your students, your startups, to start now. They don't have to wait 10 years for fault tolerance, right? And I think that's brilliant.
So I'm an extreme optimist, so I feel like every challenge, there's opportunity that comes out of it. And I echo everything that all the panelists here talks about. There's physical challenges with quantum on some aspects, but because we already have the infrastructure, we're continuously building on and just proving and helping the technology accelerate further and further. The talent pool, I used to think that, that's going to be a big challenge. But I'm not a quantum physicist, but we hired a quantum physicist and we had a lot of application. We are currently listing for 8 fellowships. And within the first 3 weeks, we had over 100 applications from all across the US and world. So there's lots of interest in this space, and we want to continue to build the momentum to keep Chattanooga on that cutting edge and getting the right people to come live in Chattanooga. It's beautiful there, mountains, water stuff. So come to Chattanooga, work here, and we want to continue building that the talent pool there.
Thank you, everyone on this panel. I wanted to leave a couple of minutes for questions. We are out of time, but I would just like to say to everyone in this room, you've seen Chattanooga as a case study for collaboration and ecosystem development, but I'd really like to invite you to see Chattanooga as a partner. So whether you're a researcher or a startup or an investor or industry, then don't call me, call Janet, but we'll figure that out together. Thank you.